All right, let's say we have a function g of x whose graph is like this, and you're asked to find the approximation of this, and I forgot to write the full question. Let's say the number of intervals using 6 intervals. Okay. And the question is about finding the approximation of this integral using the right sum, left sum, and the midpoint. So we have to find an approximation of the integral. The actual integral has the following meaning. It's the area under the curve, or above the curve, anything that's between the x-axis and the graph. And if it's above the x-axis, this will be counted as plus. If it's below the x-axis, this will be counted as negative. And above, it will be counted as positive. So I think because you have about the same amount of positive and negative, the actual value should be pretty close to 0. But whatever it is, we know that the midpoint rule should give you the best approximation, right? Okay, so how do we do this? Well, first, the most important formula is delta x is equal to b minus a over n, where b is the right endpoint and a is the left endpoint. And you divide it by n is the number of subintervals. Okay, so we have subintervals, and this just happens to be 6 over 6, which is 1, so that's easy for us. And the right sum is, the formula is delta x times all the values at the right endpoint. So here's the first 1, 2, 3, 4, 5, 6. You have 6 of these intervals, right? At each interval, you use the right endpoint and evaluate that value to construct this rectangle, right? This column. So you use these values, right endpoints, for each of these intervals, and you add them up. So this is 1, 0, negative 1, negative 2, 0, 1. You add them up, and you get the right sum. So the formula for this is like you evaluate f of x1, x2, all the way up till f of x6, where the convention is the very first one is called x0, and then this will be x1, x2, x3, x4, x5, x6. So this last one is x6, and you evaluate it at x1, x2, and so on and so on. See, this is really base times height. Base times height gives you this area, and then you just keep doing that and you add them up. That's the right sum. Okay. If you use the left sum, then you start from x0, the left endpoints, and you start using x0, x1, all the way up till 1 before the x6, because the left endpoint of that last interval is x5, not x6, right? So in this case, you add up till x5. And then midpoint is the same story, but this time you evaluate at the midpoint. So x0, x1 over 2, f. So you just keep evaluating the function at these midpoints. You have to see what the value of the function is at each of these midpoints. Okay. So if we do this convention, here's what we get for the right sum, because right sum is delta x times the right corner values, right endpoint values. So you have 1, 0, negative 1, negative 2, 0, and 2. That's what I wrote down, and if you actually do the calculation, it's 0. Okay. For the left sum, you start from here. That's the left endpoint, so that's going to be 4, right? And then the rest of the values are the same, and then you omit the last one because the last one is the right endpoint, not the left endpoint. So we just stop here. So all these values are computed and added up, and times delta x. Our delta x is just 1, so it doesn't do anything. So you get 2. And then finally the midpoint. Well, this is trickier. You do 1 times, you have to estimate the midpoints. So if you go you draw the midpoint, you get this value, and see, the problem is we're not given the exact formula for the function, so the best we can do is just use judgment. I think this is about 2.5, right? So this is 2.5 plus this one would be 0.3 or 4. I'll just go with 0.4. Okay, and then negative 0.4 for the next one. This is also negative. So you just use your best judgment, okay? Because the formula is not given to us, you just have to try to see what the value is. See, this is between -1 and -2, but it's closer to -2, right? So I would say minus 1.7, or some of you might think it's minus 1.6. Okay, and then this one here at the midpoint is something like -1.1. Okay, and then plus right here it's slightly bigger than 1.1, so I'll just say 1.1. Okay, so that's going to cancel these two. These two are going to cancel, I would say about 0.8, right? So these are the values of the right sum, left sum, midpoint, and the graphs. If you're doing web work for this, the graphs might be slightly different, and the endpoints might be still slightly different, but basically this is what you do.